Question 8. Right, okay, so step 1, you really need to label everything up on your diagram. So let's work our way through this. So we've got the tension in the string, which is equal and opposite towards the pulley. We've got the particle accelerating down the slope. It will therefore obviously be accelerating upwards here. Q will be accelerating upwards at the same acceleration. We have friction going the opposite direction to the movement, so that's going up the slope. We've got the normal reaction on P perpendicular to the slope, and we have the weight of P going downwards, which we can break into the two components, and we have the weight of Q going downwards. Right, so let's resolve for P. Now, I'm going to need to involve friction in my calculation when I resolve going down the slope. And one component of friction is the normal reaction. So I'm going to really need to start off by resolving perpendicular to the slope in order to allow me to work out what the normal reaction is. So F equals ma, and I'm resolving perpendicular to the slope, and I'm resolving upwards. So my normal reaction is going in that direction, and I need this component of the weight, so that's my adjacent side, so that's cos alpha. So my my net force is therefore R minus 4g, because the weight of P is 4 kilograms, so the weight, the mass of P is 4 kilograms, so the force weight is 4g. So my net force is R less this bit here, which is 4g cos alpha, equaling 0. I've been told that tan alpha equals 4/3, so that allows me to do the 3, 4, 5 triangle and have cos alpha being 3/5 and sin alpha being 4/5. So back to over here, so I've got 4 minus 4g cos alpha equals 0. Rearranging, I've got R equal 4g cos alpha is 0.6, so R equals 2.4g. My normal reaction is 2.4g, so I'm going to use that in a minute. So let's now look at resolving for P down the slope. Again, our starting point is F equals ma, so my forces going down the slope comprise the following. I've got my component of the weight, this bit here, which is 4g sin alpha, so that's 4g times 0.8, so that's my only force going down the slope. Going up the slope, I've got the friction, and remember, friction equals the coefficient of friction times the normal reaction. I'm told that the coefficient of friction is 0.5, and I've worked out the normal reaction to be 2.4g, so that is taking away my friction component, and I also need to take away the tension. So my net force is this red one here going down the slope, take away the friction and the tension going up the slope, and that force equals the mass times the acceleration, the mass of 4 times the unknown acceleration. So tidying that up, I get my first equation. I get tension equal 19.6 minus 4a. Now start again. Let's now just go and look at Q. Now Q is a lot more straightforward. I'm going to choose to resolve in an upwards direction. It's always sensible, I think, to resolve in the direction of the acceleration. So again, my starting point is F equals ma. So my net force here is tension going upwards, take away my weight going downwards. So T minus 0.5 g equals my mass of 0.5 kilograms times my acceleration, giving me a second equation when I rearrange of T equaling 0.5a plus 4.9. So there are my two equations, T equaling something, T equaling something. So let the two right hand sides equal each other, allowing me to work out the acceleration being 49/15. I then can substitute that acceleration back into either of these equations. I've taken the second one here, so substituting 49/15 back into this, I've worked out the tension to be 6.5 newtons to 2 sig figs, or 6.53 to 3 sig figs. Now for part B, I need to net off these two tension forces. So just popping these two tensions together, going in the same direction, the net effect is I've got this triangle here, and I need the magnitude of this resultant force. So what have I done here? I've really gone back and said I know that my alpha, cos alpha is 0.6, so my so inverse cosing both sides, I've got alpha being 53.1 degrees. So so this angle here is 90 degrees plus the 53.1, and because this is an isosceles triangle, these two lengths are the same, obviously with equal tensions, that allows me to say that these two base angles are equal. So those two angles together equal 180 minus 90 minus alpha. So each of those angles on its own is 90 minus alpha over 2, which is 18.43 degrees. So having worked out that these are both 18.43 degrees, I can then use the sine rule and say f over sine these two together, 143.1, equals my tension of 6.53 divided by sin this angle here of 18.43. Obviously multiplying both sides by sine 143.1, I get the force being 12 newtons or 12.4 newtons to 3 sig figs. There may be other ways to work this out, I'm not sure, but the sine rule seemed to be the easiest one to me.